Year 9 Construction Lesson 1 Part 2 Constructing an Angle Bisector. So you're now going to see a demonstration of how to construct an angle bisector. Don't make any notes during this part of the video, just watch it through, make sure you understand it, and then afterwards some slides will come up which recap the process and you can use those to practice the construction yourself and to make the notes. So we're now going to have a look at how we can construct an angle bisector. So I have here an 80-degree angle, and what we're going to do is use a pair of compasses and a sharp pencil to bisect this angle or split it in half. Again, you've seen this before in year 8. What we're going to do is review this idea to refresh our memory of it. So my first job is to open up my compasses, and I'm going to place the pinpoint here at this vertex where the two line segments join. I'm just going to stretch it out a little bit. There's no particular measurement, set measurement to which I stretch this out. And I'm going to draw an arc which cuts across both of these two line segments. Again, if you want to draw the whole circle, you can do, but there's no need. It's a little bit faint, so I will go over it. Ideally, you should try and do this in one swoop. So I'm going to label this point here A, and hopefully you can see this point of intersection where the arc meets the line segment, and I'm going to call that point P, and similarly I'm going to label this one point Q, this intersection. Now I'm going to take my compasses and I'm going to leave them set as they are, and I'm going to pinpoint at P, and I'm going to draw an arc which is centred at P. So again, this could be a circle if I drew the whole thing, but I'm not going to. I'm going to draw an arc centred at P. Okay? Now again, I'm going to keep my compasses set as they are, so not changing the width, and I'm going to put my pinpoint at Q, like that. And I'm going to draw another arc which will cross over the one that I've just drawn, and they intersect like that. So just to review, I drew an arc centred at P, like that, and then I switched over, keeping the same width again, and drew an arc centred at Q. Okay. Now, where these two arcs intersect, let's make a mark there, and I'll call that point R. And what I'm going to do is take a ruler, and I'm going to join point A over here with point R as accurately as possible. So try and be as precise as you can. The more precise you are, the better your result will be. Now, what have I created? Well, this line here is the angle bisector. And which angle has it bisected? It's bisected angle QAP. Now let's have a look. I told you that angle QAP was equal to 80 degrees. So let's measure angle QAR. Can you see it's 40 degrees? Hopefully you can just about see that. And then 40 degrees from here to here. So RAP is also 40 degrees. So that angle there is 40 degrees, and this angle here is also 40 degrees. And our angle bisector cuts across like that, splitting the angle into two equal sized angles. Now, why does this work? Well, it works by, first of all, drawing this arc here, which is centred at point A. That then allows us to identify two crucial points. It allows us to identify point Q and point P. Now, the special thing about points Q and P is because they're on a circle which is centred at A, they are both the same distance from A. So AQ is equal to AP. They're equidistant from point A. Now, we then draw in two more arcs. We draw in this arc here, which is centred at point P. So all the points on that arc are equidistant from point P. And we draw in this arc here, which is centred on point Q. So all the points on the blue arc are equidistant or the same distance from point Q. So what's special about point R? R is equidistant between P and Q. It's exactly the same distance from P as it is from Q. So I could just write PR is equal to QR. And so when we join point A with point R, we're then finding all of the points on this green line here, which are exactly the same distance from A to P as they are from A to Q. And that then causes this angle here to be split in half. Now, another way of actually visualising this, and it can be a little bit confusing to actually draw this in, so you may not want to draw this in on your own diagram, but we've actually created a rhombus. So if I join up P and R and Q, can you see we've created a rhombus? We know the distance between A and P is the same as the distance between A and Q, and because we didn't change the compasses when we drew this arc here and this arc here, then this distance here is the same as this distance here. And as a result, when we join up point A and point R, we're drawing a diagonal from one point of a rhombus to another point of a rhombus, which splits this angle here into two equal halves. So that's another way of thinking about why an angle bisection actually works, using accurate construction.
So let's review the steps that you have just seen in the previous part of the video. So step 1, set your compasses to a width of your choice and draw an arc which is centred at point A. So you can see the red arc centred at point A in the diagram. Now on your diagram, mark the 2 points P and Q where the arc you've drawn intersects the two line segments. Now keep the width of the compasses the same as when you drew the first arc, the red arc. Place the pin of the compasses at P and draw an arc which is centred at P. So you can see the blue arc which is centred at point P. Now place the pinpoint of the compasses at point Q and draw another arc which is now centred at point Q. You must keep the width of the compasses the same throughout this transformation. Now you're going to label the point at which these two new arcs intersect as point R, and you're going to join A to R using a straight line. And this line here that you've just drawn, this is the angle bisector of angle QAP.